All right, guys, trapezoids. So, 6.5, Unit 6, Section 5, all about those trapezoids. A trapezoid is a quadrilateral, but it is not a parallelogram because opposite sides are not parallel. It will have a set of parallel sides, but only one. Okay, so properties of non-isosceles trapezoids. So isosceles is where two sides are the same. Non-isosceles would be that there are no two sides that are the same. So only one pair of opposite sides are parallel. That makes it a trapezoid. And then consecutive angles between parallel lines are supplementary. So consecutive angles between. So let's do some highlighting here. So this angle and that angle, the ones between, are supplementary. And this is because whenever you do the parallel lines, those are consecutive interior angles, right? And so then also, let's go with orange this time. This angle and that angle are supplementary. They add to be 180. These add to equal 180. Okay, but not consecutively along the parallel line necessarily. So watch out for that. Isosceles trapezoids have the same properties as non-isosceles trapezoids, plus you add these. So there is only one pair of opposite sides. The consecutive angles between the parallel lines are supplementary. Non-parallel sides, called the legs, are congruent. So let's go highlighter on that. That would be this thing and that thing. Those are the legs. They're congruent. The diagonals are congruent. So if we go back to, let's just do a different color. We'll go green. This is congruent to that. The base angles are congruent. Oh, let's get really weird. Let's do here and here. Those are the base angles. Those are going to be congruent. And the opposite angles are supplementary. Okay. So angles that are on opposite sides are going to be supplementary to each other. They'll add to 90. Put that back on yellow. Okay. All kinds of rules to memorize. So let's practice those rules and help us memorize. Find each missing value of the trapezoids below. Well, if we look back, this one's going to be non-isosceles. So consecutive angles are going to be supplementary. So let's go 180 minus 87. That's going to make that 93. Should be degrees on that one. And 180 minus 51, no, that's a 4, 51, is 129 degrees. Total should be 360. We learned that about these kinds of things before. So we know those. Measure of angle K, 129 degrees. Measure of angle M, 93 degrees. That's all they needed from that one. You go ahead, pause, try number 2. Let's see how you do. Okay, here we go. We're just 180. Minus 62, that's only 80. So let's do 180 minus 62 is 118, and 180 minus whatever the heck number that was, 31, 149. So 149 degrees, 118 degrees, so 118, 149. Bing, bang, boom. Now, the orientation of these is going to be rotated and changed and all that kind of stuff, but that shouldn't matter too much. The parallel lines are where they are, so we know which ones are supplementary. So here we've got algebra involved, and what we know is those are consecutive between parallels, so 54 plus 8x plus 6 should equal 180. So that's 8x plus 60 equals 180. So, oops, let's take that back a step. Let's subtract 60. 8x equals 120 divided by 8. X equals 15. And we were solving for x, so all I need to do is solve for x. I can do that. Let's get my calculator ready to do some stuff. Find the measure of angle R. So this time we have to find x and then plug it in there. Go ahead and pause it, see if you can come up with a plan, work it out, and let's see what you get. Consecutive angles are supplementary, so 12x plus 3 plus 7x minus 13 equals 180. So that's 19x minus 10 equals 180. Let's add 10. 19x equals 190. Let's divide by 19. Drop that to a 1. So x is 10. Do we need x? No, we need to plug it in. So let's plug it in. I'm going to plug it in for this one. 70 minus 13 is 70 minus 10 is 60 minus 3 is 57. So the measure of angle R equals 57. All right, let's look at number 5. Number 5's pretty easy. At least it should be. Easy, easy, lemon squeezy. DEFG is an isosceles trapezoid, so I already know that this is the same as that. Okay. So, what are the rules? D to G is congruent to, well, E to F. And D to F, that's the diagonal, is congruent to G, no, E to G. We'll put that down as E to G. That's all we have to do on that one, nice and easy. We know that this is the same as that. And what else do we know? We know that base angles are congruent. Now, when we say base angles are congruent, we could actually say that this guy, well, and then really it needs to be a different color. So let's go with, yeah, I don't know, blue, try blue. This guy and that guy are also congruent to each other. I mean, they're not really base, but if you flip that upside down, then it'd be the base. So angle T is congruent to angle U, and angle, I think that's a typo. Angle V is congruent to angle double V, or sometimes known as W if you round the bottoms of it. But yeah, the should be base angles are the same. So another way that we can mark that is you could put the little arc through here like this, and you can put the little double arc through here like that, okay, if you wanted to. So if that one's 112, then this one's 112, and we know that they're supplementary, so 180 minus 112 is 68. I don't even know what the question asks yet, but I'm just putting some info on there. Well, measure of angle Q, 112 degrees. Measure of angle R, 68 degrees. Measure of angle S, 68 degrees. Nice and easy. So we know this one's 47 degrees. And let's find the supplement, 180 minus 47. That's weird. 180 minus 47, 133, 133 degrees. 133 degrees. Measure of angle W is 47 degrees as well. 133 degrees, 133 degrees. Nice and easy. Let's get algebraic. If M and OP is an isosceles trapezoid, we know that this is the same as that. We know that this is the same as that. We know that this is the same as that. We know that this and that is the same as this and that, because the whole things are equal to each other. So, if MP is 16x minus 13, and NO is 9x plus 8, and PN all the way across the diagonal is 5y plus 19, and MO all the way across the diagonal is 12y minus 37, solve for x and y. Well, one set is the x's, that's the outside sides. So we can do 16x minus 13 equals 9x plus 8. And let's just change color for, we can do 12y minus 37 equal to 5y plus 19, because the diagonals are congruent. So let's go back and solve for x first. Subtract 9x both sides. That leaves me with 7x minus 13 equals 8. Let's add 13. 7x equals 21. Divide by 7. X equals 3. And I'm going to go, oh, wrong pin, but let's go greeny. Minus 5y. 7y minus 37 equals 19. Add 37. 7y equals, let's see, 47. 56 divided by 7. Y equals 8. And we've solved for both. If ABCD is an isosceles trapezoid, we know this is congruent to that. Find each missing angle. Well, we know that this is congruent to these. So 5x minus 12 equals 2x plus 27 minus 2x. We got to find each missing angle. Okay, so not just x. Got to plug it in. So 3x minus 12 equals 27. Add 12. 3x equals 39. Divide by 3. X equals 13. Let's plug it in. 2 times 13 plus 27. 26 plus 27. See, 2 25s is 50 plus 1, 2, 3 more. So that should be 53 for this angle and that angle. So let's mark those. That was angle D and C. Those are 53 degrees. And we know that the ones above are congruent and they're supplementary to the ones on bottom. So 180 minus 53 is 127. 127. Put some... a little note on this. As you can see, I'm definitely having to do some work written down on the piece of paper here. So if you're giving me worksheets in this unit that don't have any work, I know where you got it. Number 11. JKM is an isosceles trapezoid. Mark those sides. Find each missing angle. Okay, well, what we know about those is they're supplementary. So 10x minus 33 plus 4x plus 17 equals 180. 14x, negative 33 down 17. So down 10 would be 23. Down 7 would be negative 16 equals 180. Let's add 16. Add 16. So 14x equals 196. Does it? It does. Divided by 14, leave a trail. X is 14, but we don't solve for x, we solve for the angle. So, I'm going to do the 10, right? Because 10 times 14 minus 33, 140 minus 33. Down 30 is 110, down 3 is 107. So this one's 107, so is this one. And to get to 80, 3 goes to 110, and then 70 more, so 73. So J, K, 107, 107, 73, 73. If you want, give it a pause, try the rest, let's see what you can do. Okay, here I go. It's isosceles. Find each missing angle. Well, those are going to be supplementary because the consecutive ones are going to be supplementary. So I can go ahead and say that 10x plus 5 plus 6x minus 1 equals 180 because this is 6x minus 1. And that's 10x plus 5. So 16x plus 4 equals 180. Minus 4 from both sides. 16x equals 176. Divide by 16. Does she go? 11 times. We don't need 11, but we need to plug it in. I'm going to do 6 times 11 minus 1, which is 66 minus 1, which is 65. So this is 65 degrees. So that's y and z. There's 65 degrees. And all it needs is the supplement. So 180 minus 65 is 115. If CDEF is Isosceles trapezoid, find the missing angle. Those are again consecutive, so 21x minus 16 plus 18x plus 5 equals 180. 39x minus 11 equals 180. Add 11. 39 equals 191. Divide by 39. Let's see, 191 divided by 39. Well, that doesn't seem to go. Did we math correctly? Oh, look at that. Fraction is a weird idea, so let's go back and look at what we did. Let's go back and look at our notes. What do we know about isosceles? Oh, those top ones are equal, not consecutive. Those are equal to each other. All right, let's get all that out of the way. Did I touch everybody? Okay, good. Now, it should be 21x minus 16 equals 18x plus 5. Should have been screaming at me, kiddos. Minus 18x. You know that those top ones are congruent. We should have done this, and we should have done that. That would have been a better clue. Mark the whole trapezoid. So we got 3x minus 16 equals 5. Let's add 16 to both sides. 3x equals 21. Divide by 3. X equals 7. There we go. That's a whole number that we like to see. Neither of them are easy, but adding 5 is easy, so I'm going to do 18 times 7 plus 5. 70 plus 56 makes 126 plus 5 makes 131. So this should be 131 degrees. So is this one, which makes 180 minus 131. Yay, big fat fingers. 49s here in the corners. So we'll just mark those bad boys. So 131, 131, 49, 49, and 1 to go. We know that this is the same. It looks a little upside down because the bigger side's on the top, but that's okay. I'm going to go ahead and mark these since we got it wrong on the last one. Twofer, twofer. So they're not the same hash marks, so that means they are supplementary this time. So 3x plus 1 plus 14x minus 25 should equal 180. So 17x minus 24 equals 180. Let's add 24. So 17x equals 204 divided by 17. What is x? 204 divided by 17 is 12. And let's plug it in. 3 times 12 plus 1. Very easy. That should be 36 plus 1, which is 37. That should be 37 degrees. And 180 minus 30, that's a 4. 37 is 143. So, boom, boom, fill them in, boom. 37 degrees, 37 degrees, 143 degrees, 143 degrees. And there you have it. Trapezoids, regular and isosceles, not regular, but normal trapezoids, and then isosceles trapezoids, where two sides are congruent.